Hi there, it's Ellen Weatherford.
And Christian Weatherford.
And we're here with Just the Zoo of Us, your favorite animal review podcast, where we take your favorite animals and rate them out of 10 in the categories of effectiveness, ingenuity, and aesthetics.
We are not zoological experts, but we try our best to get the most accurate information we can.
And we are here not playing Baldur's Gate 3.
It pains me so.
So that we can talk to you about animals at great personal cost. And before we get into this week's animals, I did want to mention that we are going to be participating with some of our friends from our Discord in the All for Animals walk at the Woodland Park Zoo in Seattle, Washington. That is going to be on Saturday, September 16th. Some folks from the Discord have put together a team for people who enjoy this podcast and want to do this really cool zoo fundraiser walk together. So I'll have a link to the page for it in the episode description. And also, if you want to discuss details and get in on the conversation and things like that, you can join our Discord. I'm really looking forward to it. I think it's going to be a lot of fun. I really like that zoo. We've been a couple times now.
Mm-hmm.
We just went, actually. Like last weekend, I think it was.
We did. We got to see the bears real good.
Oh, the bears were up so close. They were swimming in the water and we were like right next to them. And like the bear climbed up on this giant rock and looked very majestic. And I took a picture of the bear. And luckily the bear was like at just the right angle where I could take a picture framed in such a way where you could not see any indication that it was a zoo exhibit around it.
Mm-hmm.
And so when I sent it to my family, they minorly panicked that I had encountered this bear outside of a sort of zoo setting.
Mm-hmm. Yeah. So lesson learned there is don't send family picture of a potentially wild bear and then don't message again hours later.
No further context provided. I did not tell anybody I was at the zoo. It was just dropped in the group chat. And then being the way that I am, I did not respond to any further messages that they sent me asking for details after that. So to them, it just looked like there was a picture that I had taken of a bear very, very, very up close and then no further responses. So it's a good zoo.
Yes.
And this week, it's my turn to go first. And this week, I will be talking about the leaf sheep. Scientific name, Costaciella kuroshimai.
Is it either of those things?
No, it's neither, actually. Closer to a leaf than to a sheep in some ways.
Well then.
Yeah, this is actually a sea slug.
Ooh.
Yeah, I guess you could call it a leaf sheep sea slug, but leaf sheep is like cute and catchy.
Mm-hmm.
The species was submitted by Jordan Brown and Ashley Johnson. Thank you both. So if you're not familiar with what I mean when I say the leaf sheep, it is a tiny sea slug covered in speckled green leaf-like protrusions called serrata all over their body. It looks like if a hedgehog was also a succulent. It's like a hedgehog if they had like succulent sort of like spines out of their
grass type Sonic.
Yes. Like Shaman from Pokemon. Their head also has two long tentacles that kind of look like bunny ears, and then a pair of cartoony black dot eyes right in the middle of the tentacles.
Interesting.
Yeah, it looks kind of silly actually. Their whole head definitely has a sort of like cartoon cow. Almost feels like the like Harvest Moon cow like
all right.
look to it. It's very cute. It's a very cute little sea slug. And they are tiny. They are typically only about 8 millimeters, which is about a third of an inch.
That's very little.
They're very little. It makes me wonder if I were to even see one, would I even notice it? They're so tiny.
Probably not. No.
I definitely have not seen these because they are found off the coasts of Japan, the Philippines, and Indonesia.
Okay.
And I've never been to those places, so I haven't seen the species.
Sure.
But they belong to a taxonomic group called Sacoglossa, the Sacoglossan sea slugs. I was devastated to find out that they are not nudibranchs, like I thought they were, because I thought I was going to get a redemption arc by saying nudibranch correctly this time.
Well...
In one of our very, very first episodes, I talked about the blue dragon sea slug, which is a nudibranch, but I pronounced nudibranch incorrectly for the entire episode.
Well.
And so I thought I was going to have a chance to right that wrong today. Not quite, but I'm doing it now.
Self-fulfilling prophecy.
Yeah, I had to work that in there. But okay, so here's the thing about the taxonomic group that they belong to.
Mm-hmm.
In terms of like how I'm framing this episode, how I'm setting up this episode, you might imagine yourself a guard at the gates of Troy, and I approach with a gift, a giant wooden sea slug.
Mm-hmm.
It's so cute. You usher it with a warm welcome into the gates of your ears.
What?
And then night falls. And the wooden sea slug opens. And oh no, look what's inside. It's hundreds of other species of sea slug.
What?
I'm actually going to be talking about all of the Sacaglossan sea slugs.
Oh, why is that?
Because they're all really, really interesting. And the traits that are really interesting about the leaf sheep are shared by a lot of the other members of this group. But there are traits in this group that, as far as I know, the leaf sheep doesn't have. But I can't not talk about them.
Okay.
Because they're bonkers, bananas, wild. And so I didn't want to talk about the leaf sheep and leave all these other cool Sacaglossans behind. So
Fair.
I'm using the leaf sheep as kind of like the adorable, cute, don't you want to learn about it, ambassador.
Mm-hmm.
It's the Trojan horse
I see.
that I'm using to sort of usher in all of these sea slugs.
See, when you said enter your ears, it took a surprising amount of time for me to realize you weren't talking about perhaps an animal that literally finds its way into your ear to release other things.
No. I meant like, because this is a podcast and
Yes.
you're listening to
Yes,
it.
it took me a while to get there, unfortunately.
Oh, I'm sorry about that. That's a troubling mental image. I'm sorry for anyone I did that to.
I was ready for it.
So I'm not just going to be talking about the leaf sheep today.
Right.
I was trying to be dramatic about it. Okay.
I'm there now. It's
Okay.
just
We took the journey together at least. So yeah, there are nearly 300 species of Sacaglossan sea slug with bizarre and fascinating traits that I will be telling you about today. And I did want to also include that another listener, Evan Barclay, actually requested sea slugs of the genus Elysia, which are also Sacaglossans and will be featured during this segment because they have their own very, very cool stuff going on that the leaf sheep doesn't. So I will be talking about that. So starting off, if this is your first time ever listening to this podcast, we rate animals out of 10. And the first category is effectiveness, which are physical adaptations. How good are the tools this animal has built into their body that allow them to do the things they're trying to do as an animal? And I'm giving these sea slugs a 9 out of 10 for effectiveness.
It's very good.
And the very first thing is probably the thing that this whole group of sea slugs, including the leaf sheep, is most known for. And it's called kleptoplasty.
Kleptoplasty.
So you may recognize some of those prefixes and suffixes. Do you remember klepto?
To steal.
Yes. What about plasty? What do you think the plast is?
Tissue?
Chloroplast.
Huh.
They eat algae. And algae is full of chloroplasts. So chloroplasts are a type of tiny organelle that allows cells to perform photosynthesis.
Oh, okay.
Yes. This is typically only found in plant cells and algae, which are like kind of like plants, but not really plants. So chloroplasts allow cells to convert light into energy. That's what plants do. They're also what give plants their green color.
Right.
So, some types of Sacaglossans, like the leaf sheep, they don't just digest the chloroplasts when they eat the algae, but they absorb it into their own body tissue, store it, and use it for themselves, allowing them to actually perform photosynthesis within their own body.
Okay, got the solar upgrade.
Yes, they have a little solar power option. Now, photosynthesis doesn't generate that much energy. It's fine for plants, which don't move, so they don't need that much energy.
Digest, don't need to circulate blood.
Yeah, there's a lot of stuff they don't need to do. So like
Extremely low metabolism.
Yeah, they can get by on a small amount of energy, but for animals, it's not enough to survive on. So sea slugs seem to really only use it to supplement their regular diet. So some of them feed on algae that seasonally calcifies. during like some parts of the year, that algae might not be edible for like months at a time. So they use photosynthesis to kind of get them by until it's the right season. But it's not clear how they're able to integrate the chloroplasts into their own cells, because chloroplasts usually need to be like hooked up basically to like specific proteins in their like host cell in order to work. It would be like trying to like charge your phone with a potato. It's like you don't have anything to hook it up to, right? Like what do you do with it? Like you don't have the right equipment or hardware. You just don't have the right equipment for that.
Sure.
So there must be some sort of cellular mechanisms that the sea slugs are able to use to not just store, but actually like use the chloroplasts in that way. Like there must be something at the cellular level that they're able to hook up to the chloroplast to let them work that way.
I would have guessed it was not so direct. I guess I would have thought the photosynthesis was creating a byproduct that it was then using.
Well, I mean, I don't know. It may be something like that, but I mean, it seems like they're able to get by on just photosynthesis. Like some of the papers that I read suggested that there may have been some lateral gene transfer between animals and plants.
Wow.
Yeah, which would be really interesting. Still something that like hasn't really been fully like fleshed out in the research yet. I just think it's pretty interesting that they're able to like eat plants and then like gain plant powers. Like that's such a sci-fi move, right? Like like Kirby, how like he eats stuff and gains its powers, right? Like imagine if we could do stuff like that.
What power do you get from peanut butter?
What if you could like eat sushi and then like be able to breathe underwater? Like that'd be so cool, right?
Sure.
So yeah,
there's a My Hero Academia person like that, by the way.
Which person is that?
I don't recall his name, unfortunately.
Okay. I'm sorry.
But his whole thing was eat food, do the thing that animal could do.
Oh, that seems largely useless in terms of like eating domesticated animals.
Well, it included things like octopus and a little more exotic things.
I forgot that people eat octopuses. Yeah, that actually makes a lot more sense.
A very minor character in the show, I'll say.
I did want to say that I got all that information from the paper Functional Chloroplasts in Metazoan Cells, a Unique Evolutionary Strategy in Animal Life. That's by Katharina Handler et al. In Frontiers in Zoology in December of 2009. And just if you would allow me a brief detour, because I learned something while reading this and that destroyed my entire brain from the inside out.
I'll allow it, yeah.
So chloroplasts in plant cells, they're being stolen by the sea slug in this instance. The chloroplasts in plant cells were already stolen to begin with. They originally belonged to a prokaryote, a single-celled organism that does not have a nucleus, that got swallowed by a eukaryotic cell that has like a nucleus. I'm talking like billions of years ago.
Okay.
And when the eukaryotic cell swallowed the prokaryotic cell, instead of just like digesting it and it dissolves and that's the end of it, they formed a symbiotic relationship. And like the prokaryote became like an endosymbiont, I guess. And over time, the rest of the prokaryote just like went away. And the chloroplast is all that's left of this like ancient symbiotic relationship between two different types of organisms and left them with a chloroplast.
Well then.
Is that not the craziest thing you've ever heard?
Yeah.
I just thought that was cool. I wanted to mention it.
Because I'm assuming the sea slugs are getting their chloroplasts from the things it eats,
yes,
right? Like
from
this
the
is
algae.
not something it's inheriting from its parents. Okay.
Right. Yeah, they have to eat the algae to get the... And also the chloroplast doesn't live forever inside their body. It can only live for like a few months at a time. I think usually it's around like 4 to 5 months, but I saw some papers that said up to 10 months. So they do have to like continually eat algae to like replenish their chloroplast. They can't just like eat it and then it's part of them forever.
Plant queen.
Slay. Now, in the same vein, I want to talk about something else, a different klepto. It's called kleptochemistry. And this has actually not been shown in leaf sheep, which is why I wanted to zoom out into like the Sacoglossan group in general. Because this is not something shown in leaf sheep, but in other types of Sacoglossan sea slugs. They can actually absorb the chemical defenses of the algae that they eat and use it for themselves to deter their own predators.
All right.
So these are sea slugs, right? They don't have a big shell to protect them. They're not poisonous or anything like that. They need some way to protect themselves from predators. So they eat algae that has its own chemical deterrents, and then they steal it. Kind of like the blue dragon sea slug that we talked about a long time ago. It like sequesters it in its own cerata and like uses it for its own defenses. If you can't make your own chemical defenses, then store-bought is fine.
And then launch it at your enemies.
It's not a launching thing. I think it's something that they just like keep in their body, and then like if something eats them, then they taste bad.
I was thinking of the blue sea dragon with the what were those called? The stinging cells?
Oh, the nematocysts.
Yeah.
Yeah. Even that I think is the sort of thing where you still have to like touch it.
But then it like kind of like launches into the cell from like that touch. Yeah.
Yeah, it seems like sea slugs are really good at like stealing stuff. I love stealing.
I'm going to use this.
You made this? I made this. And I got that from a paper called Chemical Defenses in Saccogloss Apithsabranchs, Taxonomic Trends and Evolutive Implications by Arnaldo Marin and Juan Domenic Ros in Scientia Marina in April of 2004.
Evolutive.
Evolutive, maybe? Evolutive? Evolutive.
Interesting.
But the green color of the chloroplasts also helps them with camouflage because it turns their body green and helps them blend in with like the algae that they're eating.
Is that where they're hanging out usually?
Yeah, they're kind of like grazing on the algae, so they're kind of hanging out around it.
Is this where the actual sheep part comes into play?
Yeah.
Because so far I was like, none of this sounds sheep-like.
They do kind of like hang out on like algae and seaweed and stuff, and it looks like they're just kind of like peacefully grazing. Very sheep-like.
I got it.
And the last thing that I wanted to talk about for effectiveness is also something that is not shown in the leaf sheep specifically, but it has been identified in different photosynthetic saccogloss species in the genus Elysia, so the one that listener Evan had requested, actually. A 2021 study identified extreme autotomy in sea slugs. Do you remember the word autotomy? We've talked about it before.
Is this where you can drop a tail and grow it back?
Yes. I was going to say, welcome to Pop Quizzing Christian Hour. Yes, it is that. So autotomy is the ability to intentionally discard an appendage, such as when a lizard drops their tail, just like you said. So the sea slugs in this study were able to detach. What do you think I'm about to say next?
Is it their head?
Their head, yes.
I feel like I might have heard this before.
They can fully rip their own head off and just abandon the rest of their body.
It's quite the power move.
Like a mech pilot hitting eject and just completely separating from the rest of their entire body.
Huh. What part are they trying to leave behind?
All of it. The whole thing. They leave the whole thing behind.
The body.
Yes. All of it.
But so the head continues on.
Yes.
Okay.
So it seems there's some really interesting stuff going on here. So I'll read a quote from the paper.
Technically speaking, they're detaching their body.
Well, yes. So here's the quote. They say, surprisingly, they shed the main body, including the whole heart, and regenerated a new body. In contrast, the shed body did not regenerate the head. Okay. So they can't just do this to like reproduce, right? They can't just split themselves in half. Some types of worms can do that, but they can't do this.
Right.
Now, here's another thing. The researchers also noticed that this process consistently occurred at a groove that runs across the sea slug's neck. So the researchers suggested that this is actually a predetermined breakage plane. Like, to me, it reminds me of those old plastic Kool-Aid bottles. You know what I'm talking about? How they had the notch at the top where you were supposed to just like snap it off? Sure. There's like a spot where you're supposed to snap it off, right?
Perforated.
Yeah, they have a perforated head, I guess. But this is kind of a strange process because it happens in the exact same spot, so it looks like they're ready to go. They're pre-built, ready to abandon body at a moment's notice. But the whole process of splitting their head off from their body takes like multiple hours. It's not something that they just like yoink and then are done with, right? It doesn't seem to be helpful for escaping a predator the way that a lizard would drop their tail, right?
Right.
Because if it's going to take you hours to do, whatever's trying to eat you has already eaten you at that point.
Unless you're like escaping a sea urchin or something.
Now, some of the things down there that might help with. But what the researchers believed it's actually used for is to rid the body of parasites. So all of the sea slugs in the study had parasites before decapitating themselves and then didn't have any once they regenerated their body.
I see.
So it seems like a hard reset on the entire body, just restore to factory settings, like just power cycle the whole body, I guess.
I wonder what the mechanism is of how to send a signal to start that process.
I don't know, because, they don't have any other like behaviors that they can do to rid themselves of parasites. They don't have any hands or like some, fish might jump out of the water to knock parasites off or something, but they can't do that. Now, this study specified internal parasites.
Okay.
So it seems like something where the slug's body is able to like sound an alarm, be like, hey, it's not going so good, abandon ship.
Well, that makes me wonder, is it something that it chooses to do, or if it's more just a bodily reaction to it?
Right.
Like how you, like if you eat something nasty enough, you throw up. Like you don't decide to throw up. It just happens.
Well, based on what I know about sea slugs, I don't think they decide to do anything ever.
Right.
I think it's just like a reflex, I think they're just like, oh no, here I go. Goodbye.
You get that tingly feeling, and then, about to lose my body.
I gotta find a toilet.
I gotta wrap up my errands.
Oh, and it's gotta suck that like they do that and then they lose all their chloroplasts that they had been like working so hard to build up in their body. Now they gotta start all over again.
Fresh slate. Almost said flesh slate.
New body, new me. And by the way, the paper I got all that from is called Extreme Autotomy and Whole Body Regeneration in Photosynthetic Sea Slugs by Sayaka Mito and Yoichi Yusa. That was in Current Biology in March of 2021. So you see why I couldn't read this paper title at the beginning of the episode, because it gives you every piece of information I'm going to talk about.
Yeah. Great for research papers, not great for podcasts.
No, I have to build suspense and tension and a narrative. Oh, also in that paper, there are pictures of the entire process.
Oh.
So you can see like the little sea slug when it's just a head with the nub. And then like you can see it regrow its entire body in photos. It's really, really cool. So that wraps up effectiveness. They have a lot of tools in their kit, right? Like they're able to make it work. Even though slow and soft, they are able to compensate for some of their weaknesses in some really fascinating ways. So this brings me to ingenuity for solar-powered sea slugs, which ingenuity for the purposes of our podcast is behavioral adaptations, things the animal is doing with their body to gain an advantage or solve problems they face. I'm giving this one what I think is a generous 2 out of 10.
Yeah.
They
sound like they're along for the ride.
Yeah. I mean, there's just not a lot happening there. Like, it's just eat plant. That's all they got happening in that little noggin in there. I found a 2021 BBC travel article by Rena Diane Caballar, or possibly Caballar, in which diver and photographer Genevieve Reyes said, quote, "Leaf sheep don't hide or retract when they feel your presence. They have a routine life, circling the leaf of an algae and grazing about in their own little world." So it sounds like they don't really respond to like stuff around them. They're just unbothered.
Now, do they lack the processing ability or the sensory input?
Right. Like, is it... Well, so
both.
They do have some sensory input. So I mentioned that they have these little like bunny ears on their head. Those are actually called rhinophores, which are chemoreceptors. So they're like antenna almost. Like they're more for like detecting chemicals in the water around them.
Okay.
So like they do have that, and they have eyes, just very, simple eyes. So, I mean, I don't know if it's that they know that you're there or that they just don't care. Like,
it's probably they just don't know you're there.
No, they just... unbothered, focused, flourishing, in their lane, moisturized.
Besides themselves.
I have to give I think the 2 points I gave them they get points for minding their business, I think.
Okay.
And the final category that we rate animals on is aesthetics. And for aesthetics, I'm giving all of these slugs a 10 out of 10. Every single one of them. No skips in this group.
Okay.
Every single one is a banger. The leaf sheep is the cutest thing in the world. It's so adorable. In the BBC travel article that I mentioned earlier, it was mentioned that divers often refer to this leaf sheep as, quote, Shaun the Sheep, due to the slug's resemblance to the animated sheep, Shaun the Sheep. Have you ever seen, I think it's by the same, like, people that did Wallace and Gromit.
Oh, yeah.
Yeah,
Okay,
that little, like, claymation, like, animated sheep. Yeah, it looks a lot like that. The face is very reminiscent of Shaun the Sheep.
I see.
It's giving Shaun the Sheep. But then other sacoglossans outside of the leaf sheep are also equally stunning. Actually, the specific type of slug that Evan requested, Elysia chlorotica, is a stunner. They're gorgeous. Their whole body looks like a bright green leaf, and it's complete with veins. It has these like veins and grooves.
Okay, yes.
It's beautiful, and they have these like gorgeous like white speckles. I'm going to pull up a picture real quick so that you can see, because I think you should see how beautiful this slug is. Look.
Wow. That is very leaf-like.
Isn't it? But like better than a leaf, I think. Because they do that sort of like undulating swimming movement where like...
That's true.
They look kind of ribbony, which is really, really cool for me. So I feel like they're just like a step up from a leaf.
Very
Like
good.
leaves are already pretty cool. Now, this is where we usually wrap up with conservation information. I cannot find any information that like specifically pertains to the current conservation status of like sacoglossan sea slugs. I found a paper that like modeled what they might be going through and like what climate change might do to them, which is not good. It's never good, right? Like it's never great. So being marine species who rely on algae and photosynthesis to survive, I have to kind of assume that they're susceptible to things like climate change in the ocean, like the changing acidification of the ocean, and issues like algae imbalances, right? When you get like, I don't know, like red tide and stuff like that.
Right.
Or nutrient runoff and hypoxia really throws the whole ocean out of whack. So I guess just be nice to the ocean, or the adorable little leaf sheep sea slug gets it.
Just add another reason onto the pile of being good ocean stewards.
I'm holding the sea slugs hostage. The sea slugs will be imperiled until morale improves. And it was the leaf sheep, but is also the solar-powered sea slugs.
Very good.
Let's take a quick break to hear from our friends on the Max Fun Network, and then we'll get to Christian's animal.
I'm Emily Heller.
And I'm Lisa Hannawalt.
And we're the hosts of Baby Geniuses.
We've been doing our podcast for over 10 years.
When we started, it was about trying to learn something new every episode.
Now it's about us trying to actively get stupider, and it's working.
Hang out with us and you'll hear us chat about
gardening,
horses,
various problems with our butts,
and all the weird stuff that makes us horny.
That's so weird, all that stuff. Baby Geniuses, a show for adult idiots.
Every other week on Maximum Fun.
Baby Geniuses, we know everything. Baby Geniuses, tell us something we don't know.
The following pro wrestling contest is scheduled for one fall. Making their way to the ring from the Tights and Fights podcast are the baddest trio of audio, the hair to beware, Danielle Radford.
It really is great hair.
The Brit with a permit to hit, Lindsay Kell.
The queen is dead. Long live the queen.
And the fast-talking, fist-clocking Hal Upland.
See, I can wrestle and be an announcer.
Get ready for tights and fight.
Listen every Saturday or face the pain.
Find us on Maximum Fun. Now ring the bell.
All right, my love, what animal do you have for us this week?
This week I'll be talking about the basilisk lizard.
I'm excited about this. This is great. This is one of those creatures that's always been like on the fringes of my like knowledge, where I'm like aware of their existence, but I have nothing else on them.
Yep. So that is genus Basiliscus, also known as the Jesus Christ lizard.
Love that.
Yes. touch on that soon.
I'm sure no one hates that. I'm sure nobody gets upset about that.
Listener Eric had submitted the specific species, the common basilisk, but I decided to zoom out to the genus.
Sure. Thank you, Eric.
Yes, thank you. So a lot of what I'm talking about might be specific to specific species versus common in all of them. And I'll be getting my information from Animal Diversity Web, National Zoo at the Smithsonian, and National Geographic.
Nice.
So first, they are lizards. So quadrupedal, long tails. Very lizard-like, if you're familiar with the lizard blueprint.
You know how lizards are? This is the platonic ideal of a lizard. You may not like it, but this is what a pink lizard looks like.
Sure. Now, these lizards, their coloration ranges from brown to olive or green. Females have a smaller crest on their head, whereas males have a more pronounced head crest and also a crest that runs down the back and tail.
Now, what does this crest look like? What's the crest situation?
The head crest reminds me of some kinds of chameleons a little bit.
Oh, like a casque moment.
Yes, yes. And then the parts on the back and tail are kind of spiny.
That's pretty cool.
Yeah. Their size is up to 800 millimeters or 2.5 feet approximately.
There has to be a better way of saying it than 800 millimeters.
8 centimeters.
There we go.
I hope I said that right. That sounds right. No, it doesn't.
Wait, hold on.
That's 80 centimeters.
Okay. I was about to say, that's not 2 feet. 8 centimeters is not 2 feet, Kristen.
Anyway. Now, 75% of that length is tail, however.
Oh, it's mostly tail going on then.
So
this is a little guy with a big tail.
Yes. They can be found in Mexico, Central America, and South America, and they are considered semi-arboreal and semi-aquatic, usually found near water.
Very near water, one might say. Adjacent to, and in fact, abutting.
They belong to the taxonomic family, oh boy.
Let's hear it.
Corydophanidae.
That was great. That was so good.
That's the helmeted iguanas / basilisks and the casque-head iguanas. So that you used the word casque earlier.
That's a great word. I like that word a lot.
Yes.
It's a great word to use to make it sound like you know special science words.
You convinced me.
It worked on you.
So I mentioned there are other species. There are 4 species in the genus, and that's the common basilisk, western basilisk, the plumed basilisk, which I noted down its species name because I thought it was interesting. So the plumed basilisk species name is Plumifrons.
Plumifrons?
Yes.
That's a pretty name. I like that.
And lastly, the brown basilisk. Getting into our first category, I'm giving it an 8 out of 10 for effectiveness.
That's pretty good.
Yes. So first, they're very good climbers, as might be suggested by being semi-arboreal.
Well, yeah, I would hope so.
Arboreal meaning living in trees.
I'd hope they'd be able to climb. How else are you going to get up there? Ride the eagles.
They use their dragon wings. So they have these long digits with claws at the end on their hands and feet. That's probably not the correct way to describe their limbs, but and next is they're very good swimmers.
When they're in the water.
Yes. They can stay submerged for 10 plus minutes, actually.
Wow.
Mm-hmm.
That's pretty good.
Yeah, so they're good swimmers.
That's better than me.
And now finally, the keystone of this animal.
Yeah, the thing you all want to hear about.
So earlier I mentioned...
Everybody was sitting here like, yeah, Christian, they can climb, they can swim.
Earlier I mentioned they're known as the Jesus Christ lizard.
Mm-hmm. Let's expand on that a little bit.
And that is because something that they're known for doing is walking on water. So in the Christian Bible, specifically the New Testament, the main character, Jesus Christ.
Stop it! Okay.
Is that a no?
No, you're good. It's okay. Keep going. The protagonist.
In the Bible, one of the things Jesus does is walks on water. I think this is told in a couple books of the New Testament, actually.
It's in there for sure.
Yeah, it's in there. It's in there.
It's a whole thing where there's a storm going on, right?
Well, the boat was because it was on an island.
Mm-hmm.
I looked at this very briefly. I'm not a religious person at all. It was on an island, and the boat basically went off without him because he wanted to stay behind by himself. And then the boat got caught in a storm, but he was like, I'll just walk, fam. He found the boat, and when he got to the boat, the storm went away. This is one of the miracles.
Right. Yeah.
Sure. Anyway, so that's why it's called the Jesus Christ lizard. So back to the lizard.
Yes.
This one can walk on water.
Tell me about that.
It can run about 4.5 meters or 15 feet across water on its hind legs before sinking and continuing to swim.
How far did you say?
15 feet.
15 feet.
Yes.
So that is like 7 or 8 of its body lengths, right?
Double checking.
It's like 2 feet long?
Yeah, sure.
Huh. That is a considerable... I couldn't do that.
Oh, no.
I could walk 0 of my body lengths across water.
So what it has that enables it to do it, well, first it has large hind feet with toe pads that helps with it. That kind of splay out the force.
Oh, toe pads.
Yes.
Oh, interesting, because like you see splayed toe pads in other species of lizards where it's used more for grip, like geckos and stuff like that. But it sounds like they have the splayed toe pads, but it's to like distribute their weight rather than like increase their surface area. Or well, I guess it's still increasing their surface area, but just for like a different application.
Right. And so I want to dig into the physics of what's going on here a little bit. So just to draw a picture of what this looks like like a lizard that is normally on all fours, all of a sudden books it from the land into the water, and when it reaches the water, or perhaps before then, it switches to a bipedal gait. So it's running on its hind legs with its front legs kind of like up.
They go into attack mode.
Just get them out of the way. And then it starts running on the back hind legs.
Oh, so the front legs are not involved with this at all?
Not at all. Nope.
Okay.
They're out of the picture for this part.
Merely a hindrance.
Yeah. So the stepping into the water has 3 phases: the slap, the stroke, and the recovery.
Okay.
I'm going to just read a quote from a paper.
Okay.
To explain this next part. During the slap phase of a step, the foot plunged vertically downwards, pushing water down and away from the foot while creating an air pocket surrounding the foot.
What?
So I'm going to stop there in the quote. There's more to it.
Okay.
I'm going to stop there. So a good example of this, I think, is if you were to take your hand and close your fingers and make a cup shape with your hand, and then you slap the surface of water.
It makes a little bubble inside your hand.
And then usually you hear a big sound when that bubble collapses on itself.
Right. Yeah, we've done this at the pool.
Yes, every time. Every time. Finley loves this.
He does. It's very funny.
So that's what I'm imagining here. During the stroke, the foot remained within this air pocket as water was pushed away from the ventral side of the foot and circulated cranially toward the dorsum. As the foot transitioned into the recovery phase, a vortex ring was shed, representing a transfer of momentum into the fluid. The foot was extracted from the water before the air pocket collapses. So it's pushing down, and then it's stroking back.
Okay.
And then it yanks the foot out of the pocket.
Oh, without popping the bubble?
Right.
Huh. Oh, that's interesting. So it's almost like they're using the bubble to walk on, not the water itself.
The importance of the bubble has to do with not getting caught by a drag.
Oh, okay.
So the slap is giving it upward momentum to keep it above the surface of the water, and then the stroke is giving it forward momentum to keep moving forward. And then what it's doing when it yanks it out, it closes all the digits and pulls it out of the pocket that is already starting to collapse, but it pulls the foot out before it touches any of the water.
Oh, I see.
Yeah.
Okay, so it's getting out of there really, really quick before physics can realize that what it's doing.
And then it just does that over and over again.
Interesting.
And then it gains some side-to-side stability by maybe splaying the foot outward from its body just to compensate for like a side-to-side falling motion.
It's very goofy.
It is, yeah.
It's very silly looking.
And it's a huge amount of energy that has to be done there.
It's very Monty Python silly walk, sort of like windmilling their feet around.
Right.
It is hilarious.
Now, I got that quote and information from the paper titled Running on Water, 3-Dimensional Force Generation by Basilisk Lizards by Hsia and Lauder in the Proceedings of the National Academy of Sciences Journal in the year 2004.
Excellent. Huh. I thought it was just that their like feet distributed their weight in such a way that it just didn't break the surface tension of the water.
Part of it, I think.
That's part of it?
I think.
Yeah.
What's strange is not anywhere in that paper mentioned surface tension.
Right.
Which I thought maybe is not involved, or are we just saying the same thing and just not using the same phrase? I wasn't sure. It was a little bit beyond me.
Sure. Because there are other animals that are able to like chill out on the surfaces of water, but they're not anywhere near as heavy as like a lizard, right?
And those can stay motionless basically on the surface tension. Yeah.
Like the pond skaters.
Yes.
And we've been seeing so many of these bugs while we've been here in Washington. They just like hang out on top of the water and they're so light that they just don't sink into the water at all.
Right. So I'm thinking it has less to do with surface tension and more to do with just being able to generate enough force in the up and forward kind of vectors and then avoiding getting dragged down by the water.
Interesting.
Now, of course, that's very energy intensive and they lose it eventually, right? And at that point, they just swim.
It's just not sustainable. I'm wondering, did you happen to come across why on earth they bother to do this instead of just swimming in the first place?
I'll mention it in Ingenuity.
Okay.
My next point here is just says Naruto reference and highlighted.
And what's that about?
A notable thing in Naruto is all the ninjas are able to walk on water.
All of them?
It's one of those early abilities that are like, oh man, we just spent weeks learning how to do this. And then from that point forward, pretty much everyone they meet knows how to do it. So like it's nothing.
It's like a level 1 spell.
Yeah.
Well, thank you for meeting our Naruto reference quota of the day. Thank you. I appreciate
Anytime. So my next thing is they're known for sleeping up high. So they sleep up in trees around 20 meters above the ground. They are diurnal, which means they are awake during the day.
Right.
So if something tries to pick them off at night when they're sleeping, they will just book it out of the tree. And if they're close enough, into the water.
That has to be so disorienting for like any predator. Because like when you see something falling into the water, you have sort of an idea of like what's going to happen next and like what direction you need to look in. And just them like bolting across the surface probably doesn't really register on like your list of expectations.
And then the last thing I want to mention is they are omnivorous. They feed on arthropods, small lizards, snakes, birds, mammals, fishes, freshwater shrimps, frogs, flowers, and fruits.
This is very lizard behavior.
So we always notice that the animals with a high number of things it can eat is less likely to have problems with finding food, right?
Right.
Moving on to the second category of ingenuity, I'm giving it 4 out of 10. Couldn't really find
4?
anything. Yeah, couldn't really find much here.
There has to be something to be said for the fact that they have like figured out that they can use physics to basically they found this sort of like no clip hack.
It just run fast.
So fast, in fact, that physics can't keep up with you.
And as I think you already came to the conclusion of it's running across water to escape predators.
Yeah, but like what I'm wondering is, like you mentioned, it's very energetically expensive. Why bother?
It's faster than swimming.
Oh, it is faster than swimming.
Yes.
Oh,
it is.
Okay.
Yeah, they're good swimmers, but the running is faster.
Oh, okay.
And then they'll run across the water as much as they can. Usually, the smaller lizards are able to go further because it becomes a scaling problem. With the larger the thing is, the energy output it grows much higher, much faster. Like for us, for someone like a human to be able to do this, the energy output would be about 6 times greater than what we're able to do.
I feel like I may have. Do you remember that show on Animal Planet, The Most Extreme?
Yes.
I feel like I have something in my brain. I don't know if I'm making it up or not, but I feel like they may have done one of those like CGI dude visualizations on The Most Extreme. You remember how they would take this green CGI dude and like mess his body up to like make whatever trait of his like scale proportionally with like that of whatever animal they're talking about.
Right.
I feel like there's one where they gave him feet like proportional to what a basilisk's feet are like, and they look like boat oars or something.
Yeah. So it's a a classic problem of the bigger something is, the stronger it is, but then it's having to work harder against things like gravity.
True. The harder they fall.
So you'll often hear things about like, oh, the beetle can lift 100 times its weight, right? Mm-hmm. You never find anything that can do that that's larger than a cat.
It's a scaling issue. It reminds me of, I've seen videos of like people that like develop video games and stuff. They'll have like a 3D model of like some, I don't know, character, creature or something like that. And if you scale their size up, they will just continue like walking at the same speed.
Oh, yeah.
But
yeah,
even if they're like the size of a skyscraper, which is extremely terrifying. And so they say that like when you scale it up, you have to also scale down their speed because like you just can't move that fast at that large of a size.
There was a ratio to that. I forget what it was though.
I saw a video where they like scaled up the assets without scaling the speed. It's hilarious.
Yeah. And then finally aesthetics. It's very regular lizard looking. Giving a 6 out of 10.
I like how this is like otherwise a completely unremarkable lizard, except for like this one thing.
It's an impressive thing, I'll say.
Yeah. If you're gonna have one thing, like it's like a gimmick lizard. It's like if you're gonna have a gimmick, it's a good one to have.
And now some just fun miscellaneous things to talk about.
Yes, please.
So the first one, conservation status. All 4 species are least concern with the IUCN.
All right. Yeah.
They're outrunning extinction.
Dang it! I was about to say it.
I had it right here. I'm sorry.
I know. Let the record show.
Let me just type something unrelated real quick. And then the next thing we'll talk about is the relation to mythology, because the name Basilisk you might recognize from old mythology tales.
Right.
In mythology, a basilisk is a crested snake hatched from an egg laid by a rooster but incubated by a toad. It's one of those things.
Now, which mythology is this?
I don't know, man. I think I saw Pliny.
Pliny?
Pliny
the Elder?
Yes.
He was Roman.
Okay. He was mentioned at one point.
Oh, Lord.
They were said to possess strong venom and a death glare, meaning if you like looked them in the eye, you would die or whatever.
Yeah, I think, did they turn you to stone if you...
This is where it gets complicated.
Okay. That's the problem with mythology.
It evolved a lot.
Yeah, it changes over time.
Now, the name comes from the Greek basiliskos, which means little king.
Oh, that's nice.
Yeah.
I actually like that. That's kind of cool. Short king.
D&D does have a basilisk, but in there it's depicted as a stocky 8-legged lizard that's very large.
Okay.
And that turns things into stone.
Oh, that's probably what I'm thinking of then.
Well, in parts of mythology, it kind of morphed into the stone or petrification thing.
Sure.
And in D&D, what it does, or the way they describe it, because this is just flavor text, really. So it uses that vision to turn something into stone, and then it bites off chunks of the stone victim, and then in its stomach, that stone turns back into organic matter.
Stop. Oh my God. That's disgusting. Someone needs to check on whoever wrote that. SRD.
Yeah. And then the last media thing, another very popular depiction was in Harry Potter.
This is where I'm a blank canvas. I got nothing on this.
So in Harry Potter, and this is the second book and movie, where it depicts a basilisk as basically a very large snake whose gaze can kill if looked at directly, and if indirectly, they are petrified. And the way they showed petrification was not turned to stone, but basically just paralyzed. But
cowards.
Yeah. And that's a big plot point, and technically a spoiler, actually.
Oh, sorry. Sorry for spoiling this thing that came out 20 years ago.
So that's the basilisk lizards.
Very interesting. Thank you, Christian. They gave such a cool name to such like an otherwise middle of the road lizard.
Yeah. I don't know, man.
Like, because like I wonder what made them decide to apply that name to this lizard. Like, I don't know of any parallels between.
I've seen some mythology descriptions give the basilisk like a rooster shaped head. So maybe the casque part of the lizard.
Maybe an aesthetic thing.
Yeah.
Interesting. You think the first like person studying these lizards was like, oh, it's just a normal lizard. Oh my God, what is it doing?
I don't know how this.
Where are you going?
I mean, obviously someone made all this up, right? Because like, from 1,000 years ago, and then people keep finding them in bestiaries or whatever.
What's happening here?
I don't know. I mean, we can kind of explain the prevalence of dragons in lots of cultures, right?
But even that, I feel like the prevalence of dragons in lots of like mythologies is only because we use the word dragon to describe like any sort of like large reptile in mythology.
Sure.
Whereas like otherwise, no, they're not really as similar as we think, but we use the same word for them. So like, whereas like, yeah, you might have a giant serpent, right? Like in multiple mythologies, but like that's because there's serpents all over the world. Like they see what's around them and incorporate it into their like mythology.
Right.
So, you know, like the dragons of like European mythology are extremely different from the dragons of like Asian or Mesoamerican mythology. So it's just because we want to like put them all into like the dragon category because that's what we have a word for. I'm a little fired up about this because recently, like, people have been, like, all in my TikTok notifications, like, the dinosaurs are actually dragons. I'm already mad about it.
DreamWorks presents.
All right. Well, thank you, my love. That was great.
Thanks.
And thank you, dear listener, for spending this time with us. We dearly appreciate you and are so glad, and I hope you have had fun and learned something with us here today. If you did have fun and learn something new here today, I would love it if you left a kind review for us on your podcast app of choice. We really appreciate it. We read all of those when people leave nice words for us, just like it's me, Jake, who is one of the people who have recently left us a very kind review that says, quote, a joyful podcast that is sure to please any animal or nature lover, no matter their age. Ellen and Christian are great hosts, conveying their appreciation for all kinds of animals through science and amazing facts. So thank you. It's me, Jake.
It's very nice.
And if you want to hang out with us online, we are on Facebook, Instagram, particularly active on Discord, and I am on TikTok. So those are all places where you can come hang out with us on the internet. If you have an animal you want to hear us talk about on the show, you can send that to me. My email address is ellen@justthezooofus.com. We would like to thank Maximum Fun for having us on their network. And if you want to learn more about the network and their shows and how you can be a part of supporting our show, you can head over to MaximumFun.org. And finally, we'd like to thank Louis Zong for our Song of the Summer theme music.
How many summers in a row now?
When did we buy it? It was in 2021, so that's 2 years strong.
All right.
Yeah. So that's all for this week. Thanks, y'all.
Thank you.
Bye.
Goodbye.
Maximum Fun,
a worker-owned network
of artist-owned shows,
supported
directly by you.